Today, we're diving into something that we all use every day, whether we realize it or not. Inference and reasoning. It's like how we connect the dots in our heads.
Right.
You know, we take what we think we know and use it to figure out what we don't.
Absolutely.
And we've got some really interesting sources for this deep dive. A Philosophy 110 course.
Okay.
An article all about AI. And even a YouTube video on how AI thinks.
You know, it's fascinating, right? Because we're constantly making these inferences all the time.
Yeah.
Whether it's something as simple as like deciding which way to go to work or, you know, like reading a news story and deciding if we believe it or not.
Exactly. And that's a thing, right?
Yeah.
Sometimes these mental leaps, these inferences, they can totally lead us astray.
Definitely.
And our sources really highlight how easily we can fall into these traps of illogical thinking. So, like, our mission today is to help you, the listener,
become a more critical thinker.
I love that.
So you can spot these faulty inferences before they, you know, trip you up.
Absolutely. Let's start with the basics. You know, our Philosophy 110 material, they define an inference as a process of reasoning, right? Moving from a premise to a conclusion.
Okay. So
a premise is something we believe to be true.
Right.
And then the conclusion is what we think follows from that premise.
I see.
They give this really cool example called the hat problem.
Oh, the hat problem. Okay.
Yeah, have you ever heard of this?
No, tell me about it.
So picture this. 3 prisoners, and each of them is wearing a hat.
Okay.
But they can only see the hats of the other prisoners, not their own.
Okay.
And the hats can be either black or white.
Okay, got it.
Now, a guard comes in and tells them, at least one of you is wearing a black hat.
Okay.
Now, the prisoner in the very back, who can see the other 2 prisoners' hats, he says,
I don't know what color my hat is.
Interesting.
Right. And then get this. The prisoner in the middle, just from hearing that, he knows his hat must be black.
Whoa, hold on. Wait, really? How does he know that?
It's all about that deductive reasoning.
Okay.
So if his hat were white, the prisoner in the back would have seen 2 white hats, right?
Right.
And he would know immediately, oh, mine must be black.
Oh, I see.
But since the guy in the back hesitated,
right,
the middle prisoner can deduce that his own hat must be black.
That's amazing. We just witnessed
That's pretty cool.
Like straight up deductive reasoning happening.
In action.
It's all about like eliminating possibilities
Yeah.
based on what must be true.
Absolutely.
But our Philosophy 110 source says inferences aren't always this, you know, clear cut.
Of course not.
They can be logical.
Logical, yeah.
Which means the reasoning makes sense.
Right.
Or illogical. Meaning
there's a flaw somewhere.
There's a flaw in the thinking.
Exactly. And let me tell you, these illogical inferences, they're everywhere.
Oh, I know.
Just think about advertising.
Ugh, yes.
How many times have we seen those ads that are like,
oh, all the time.
Nobody beats our prices.
Like that Best Buy example in the source material.
Oh, yeah. What was that?
Today, no one can beat Best Buy's prices on the new Apple iPhone.
Right.
So the lowest price for the new Apple iPhone is only at a Best Buy store.
And it sounds so convincing, right?
Right. Like, of course, they're the best. Right.
Yeah. But the premise, it might be technically true, but the conclusion, it's misleading.
Right.
Like, maybe Best Buy and the Apple Store both have the phone for the same price.
Exactly.
But the ad wants you to think that Best Buy is the only place to get the best deal.
Right. And that might not be true at all.
Not at all.
So you could end up like wasting your time and gas driving all the way to Best Buy.
Yeah.
When you could have gotten the same deal somewhere else.
And that's what the source is saying, right? Over time.
Yeah.
All these little faulty inferences, they can really add up.
That's true.
Costing us time, money, even stress.
Ugh, I know. So frustrating. And the Philosophy 110 material really like emphasizes that even if your logic is perfect, if your starting premise is wrong,
it's all going to be messed up.
Your conclusion will be way off.
Completely off.
And they have this really kind of sobering example about how important it is to start with accurate information.
Right.
Remember that internet ad for the weight loss supplement?
Oh,
Oxylite product.
Oxylite Pro, yeah.
They made all these claims about, rapid weight loss, even included testimonials.
Of course.
And it was like designed to make you think,
right.
oh, if it works for them, it'll work for me.
Classic.
Right.
Yeah.
But then remember, this supplement was linked to serious health problems.
Major problems.
So the premise, the information in the ad was dangerously flawed.
Totally.
It's a good reminder that we can't just take information at face value.
No.
Especially when it comes to...
when it comes to our health.
Yeah, our health.
Oh, yeah.
Exactly. And this is where things get really interesting.
Ooh, okay.
Artificial intelligence, AI, also relies on inferences.
That's right.
But AI takes it to a whole other level.
Definitely.
And this YouTube video we have explains AI inferencing in a way that's really easy to understand.
Oh, good.
They compare training an AI model to teaching a student.
I like that analogy.
Right. You give it all this information, show it examples, and it learns from the patterns.
Okay.
Then AI inferencing is like that student taking a test.
Oh, I see.
Right.
Yeah.
It uses what it's learned to answer new questions, make predictions, solve problems.
I get it.
So the video uses spam email detection as an example.
Okay.
An AI model gets trained on tons and tons of emails. Some are marked as spam, some aren't.
Right.
And the model learns to recognize patterns in the spam, like certain keywords, sender addresses, stuff like that.
Gotcha.
And then when you get a new email, the AI model uses those patterns to infer, is this spam or is it legit?
It's making a judgment call.
Exactly. Just like we're trying to figure out if those no one can beat our prices claims are legit.
Exactly.
But here's something that I found really surprising.
Okay.
In the IBM Research article, it says that the computational cost of AI inferencing can be way higher than the cost of training the model.
Really?
Yeah.
That's so weird.
Like counterintuitive, right?
Totally.
But when you think about it, training is like a one-time thing.
Oh, that's true. Yeah.
But inference, that's happening constantly.
Yeah. Nonstop.
Not all the time and at a massive scale.
Oh, I hadn't thought of that.
Like, think about all the AI stuff we use every day.
Oh, yeah.
Voice assistants, image recognition, all those recommendation algorithms. Every single interaction requires an inference.
Wow.
And we expect those responses to be instant.
Oh, yeah, of course.
So that takes a lot of processing power.
Yeah, that makes sense.
And that's where the cost comes in.
So it's not just the number of inferences. It's also like the complexity of the models, right?
Exactly.
The more sophisticated the model, the more power it needs for each inference.
Exactly. So as AI becomes more and more prevalent in our lives, I think understanding the cost of inference gives us a new appreciation for the resources to power all those services we take for granted.
It's true. We don't even think about it.
And it highlights why there's this constant push to make AI inference faster and more efficient.
Right.
Which is exactly what the IBM article is all about.
Okay, so what do they say?
They talk about this three-pronged approach.
Okay.
Optimizing the hardware.
Right.
Shrinking the models and improving middleware.
Interesting. So let's break those down, huh?
Yeah, let's do it.
Okay, let's start with hardware. What's that all about?
So with hardware, it's all about developing chips that are specifically designed for AI tasks.
Okay, I see.
The article talks about IBM's work on these specialized chips that are optimized for the kinds of calculations that AI needs to do.
So it's like giving AI its own super efficient brain.
Right. And it's designed to handle information in a way that's much faster and uses less energy.
Wow, that's really cool.
And then there's the idea of shrinking the AI models themselves.
Oh, okay. How do they do that?
They use these techniques called pruning and quantization.
Pruning and quantization.
Yeah, and it's basically trimming down the model without sacrificing accuracy.
Okay, that makes sense.
It's like taking a long, rambling sentence and making it short and snappy, but keeping the meaning intact.
Yeah, without losing the meaning.
Exactly.
Gotcha.
And then the last one is middleware.
Middleware.
Which acts as a translator between the hardware and the AI model's instructions.
So it's like the go-between.
Exactly.
Yeah.
And the article mentions these techniques called...
what are they called?
Graph fusion and parallel tensors.
Graph fusion?
Which optimize how those instructions are carried out by the hardware.
Okay, so it's like streamlining the communication.
Exactly. It's like streamlining the communication between the brain and the body.
I like that.
Making everything
much smoother.
Smoother and faster.
So have they seen, like, any good results with these approaches?
Yeah. The researchers have actually seen remarkable results
Really?
by combining these different approaches.
That's awesome.
Especially when working with a large language model.
Wow, that's incredible.
And they're not stopping there.
Of course not. They got to keep going.
They're constantly researching new techniques
That's
to
pushing the boundary.
Make AI inference even more efficient.
Yeah. It's amazing how much work goes on behind the scenes.
It really is, to make those AI-driven experiences that we all rely on so fast and seamless.
Totally.
Yeah.
You know, it's clear that AI inference is like a super complex and rapidly evolving field.
It really is.
With so much exciting work being done to improve its speed and efficiency.
Definitely.
But you know what?
What?
Our exploration isn't over yet.
No way.
In part 2, we're going to delve even deeper into this world of AI inference.
Oh, can't wait.
Uncovering some of the challenges and innovations that are shaping the future of this technology.
I'm so ready.
Stay tuned.
All right, we'll be right back. All right, welcome back. So in part 1, we talked about the fundamentals of inference and reasoning.
Right.
Like everything from simple logic puzzles to the complex world of AI.
Yeah.
And we even touched on how the cost of AI inference, like the computational cost, can be pretty high.
It can. And, you know, as AI becomes more and more a part of our lives, those costs are going to keep going up.
That's true.
You know what I mean?
Yeah. And it's kind of mind-blowing to think about just how much AI inferencing is happening all around us.
I know, right.
Like the IBM article mentioned that a single company might have millions of users interacting with a chatbot.
Oh, easily.
Every day.
Yeah, every single day.
And that's just one example.
Right. Think about all the other applications.
Oh, yeah.
All the industries that use AI.
It's everywhere.
It's kind of a hidden world of constant computation.
It really is.
Powering everything,
you
know. From movie recommendations to fraud detection, all that stuff. Crazy shit.
Yeah, it really makes you realize that AI is working behind the scenes, like all the time.
Totally.
Shaping so many of our digital experiences.
And, you know, all this AI inferencing happening at such a massive scale.
Yeah.
It makes you wonder about the environmental impact.
Oh, that's true.
You know?
Yeah, what about that?
The YouTube video had this, I thought it was a really striking comparison.
Yeah.
They said that, like, running a large AI model over its lifetime, it could generate more carbon emissions than an average car.
Whoa, that's a lot.
Yeah, it's pretty crazy, right?
So finding ways to make AI inference more energy efficient.
Oh, absolutely.
That seems super crucial.
Yeah, especially as AI becomes more widespread, for sure.
Absolutely.
And the good news is there's a growing awareness of this in the AI community.
That's good to hear.
The IBM article talked about a few strategies researchers are exploring to try to address this challenge.
Okay, like what?
Well, they talked about optimizing the hardware, right?
Yeah.
Making AI chips even more energy efficient.
Okay, makes sense.
And then remember that concept we talked about?
Yeah.
Shrinking the models themselves?
Oh, yeah. With the pruning and quantization?
Exactly. Pruning and quantization.
Clever stuff.
They're like clever little tricks to reduce the computational burden of inference, but without losing any accuracy.
That's awesome.
Yeah, it's all about finding shortcuts, you know?
Right.
Like faster processing, less energy.
I love it.
It's a win-win.
And then there's the middleware, right? The software that bridges the hardware and the AI models.
Yeah.
The IBM article mentioned some cool innovations there, too.
Oh, yeah. What were they called?
Graph fusion and parallel tensor.
Graph fusion, yeah.
It's all about optimizing the flow of information.
Right.
During the inference process.
Okay.
Removing bottlenecks.
So it runs smoother.
Smoother and more efficient.
It's like fine-tuning a car's engine to get better gas mileage.
I love that analogy.
It's all about optimization, right?
Yeah, and it's great to see that researchers are tackling this challenge of sustainable AI inference from all these different angles.
From all sides, that's right.
Hardware, software, the whole shebang.
And it's such a, rapidly evolving field.
It really is.
There's so much innovation happening.
Oh, yeah, for sure.
And there's this other area of research, too, that I think is super interesting.
Oh, what's that?
It's called inference scaling laws.
Inference scaling laws?
Yeah.
What are those all about?
So basically, they're trying to figure out the relationship between the computational resources you give to inference and how well the AI model performs.
So it's like if a student has more time to think about a problem, they'll probably do better on the test.
Yeah, that's a great analogy.
More time to make those inferences.
And what they're finding is that in some cases, devoting more resources to inference,
Okay.
it can lead to, like, much bigger improvements in AI performance
Really?
than just making the models bigger or training them on more data.
Wow, that's really interesting.
So it's not just about the size of the model, it's also about how efficiently it can process information
That makes sense.
and make those inferences.
Yeah.
And this has led to a shift in focus towards inference time optimization,
Okay.
which is all about, like, coming up with techniques to really maximize the performance of AI models
I see.
during
Like
inference, like making the most of the computing power you have available.
It's like training a student not only to know the material, but
Yeah.
also to like have good test-taking strategy.
Exactly. That's a perfect way to put it.
Right.
The IBM article, they mentioned some specific techniques they're exploring.
Okay, like what?
Things like best-of-n sampling and Monte Carlo tree search.
Okay, so can you break those down for me? What are those all about?
Yeah, so basically these techniques involve generating a bunch of different solutions to a problem, right?
Right.
And then they use another AI model, which they call a reward model,
Okay.
to pick the best one.
So it's like having a panel of experts
Yeah,
weigh in on a decision.
exactly. Choosing the best option.
That's awesome.
And these techniques, they're showing some really promising results,
Really?
especially for tasks that involve a lot of, like, strategic thinking and planning.
Wow, that's really cool.
So there's still a lot of room for innovation in this area,
Oh, of course.
but the potential is huge, you know?
Yeah.
Like, as we figure out how to leverage this inference time optimization even more, we can, like, unlock even greater capabilities from the AI models that we already have.
It's exciting to think about how AI inference will continue to evolve.
It is. It really is.
But in the last part of our deep dive, we're going to go even further into the future and explore something that sounds almost like science fiction.
What is it?
AI models that can engage in, get this, self-talk.
Self-talk?
Yeah.
Wow.
Stay with us. All right, welcome back to the final part of our deep dive into the world of inference.
Yeah.
We've talked about so much.
It's been a lot.
Like from the basics of how we reason as humans to this super complex world of AI inference.
Yeah, absolutely.
And all the challenges that come with it.
Yeah, it's been a journey.
But now we're going to go like full-on sci-fi.
Oh, okay.
We're talking about AI models that can talk to themselves.
Talk to themselves?
Self-talk.
Wow. Okay, now that's interesting.
Right. Sounds pretty futuristic.
Well,
right. But it's a real thing.
It is.
Yeah, self-talk in language models.
Okay.
It's actually a whole area of research.
Wow.
And it could change how AI reasons and solves problems in some pretty amazing ways.
So I'm guessing we're not talking about like AI literally whispering to itself in a data center?
No, definitely not.
Okay, so what do we mean by self-talk then?
Think of it like a structured thought process.
Okay.
So the AI generates these internal prompts and responses.
Okay.
It's almost like having a conversation with itself.
I see.
And this internal dialogue helps the model break down these big, complicated problems into smaller, more manageable steps.
Okay, so it's like giving the AI a whiteboard.
Exactly.
To brainstorm on.
Yeah. So it can like think things through from different angles before coming up with the solution.
That's a great way to put it.
And this isn't just some theory, you know.
No.
There are already AI systems that are doing this.
Really? Like what?
The article mentioned this project called Strawberry.
Strawberry, okay.
From OpenAI.
Oh, wow.
It's believed to use some kind of self-talk to boost its reasoning abilities.
Okay.
And they said that Strawberry can, like, appear to talk to itself.
Appear to talk to itself, huh?
Yeah, while it's working through, you know,
right.
these complex problems.
So what kind of problems can it solve?
Well, they gave some examples of Strawberry solving, like, hard math problems.
Whoa.
And word puzzles.
That's impressive.
Yeah. And apparently the way Strawberry works, it's still, like, top secret.
Really?
But it's clear that this self-talk thing, it's a big part of how it's able to solve these, you know, really tough problems.
So it's like really advanced then.
Yeah. And the article also talked about another project called Q.
Okay.
Which might have been like an early version of Strawberry.
Oh, interesting.
But the main idea is still the same, right?
Yeah. Use self-talk to make AI smarter.
Exactly.
I like it.
And get this. The article even hinted that OpenAI might be developing a new language model called Orion.
Orion, okay.
And this one is trained on the stuff that Strawberry comes up with.
Whoa, so it's like one AI teaching another.
Yeah, like passing down knowledge
So cool.
from one generation to the next.
So it's not just about these top secret projects, the self-talk idea. It's being used in other ways too, right?
Yeah, researchers are finding ways to use similar techniques in more widely available AI systems.
Okay, that makes sense.
Remember those techniques we talked about, best-of-n sampling and Monte Carlo tree search?
Yeah, those are the ones where the AI generates a bunch of options, right?
Exactly.
And then picks the best one.
Right, and while that's not like self-talk in the literal sense, it's still kind of a form of internal deliberation.
I see.
The AI is considering different options before it makes a final decision.
So it's like the AI is having a debate with itself.
Yeah, exactly. Weighing the pros and cons.
That's really cool.
And it's actually working.
It is.
Yeah, these techniques are helping AI get better at solving problems.
Wow.
Especially problems that involve, like, strategic thinking and planning.
Okay, so that's the good side.
Right.
But what about us?
What do you mean?
Like, if the AI is spending all this time talking to itself, won't that make things slower for us?
That's a good point, and researchers are definitely thinking about that. They're trying to make self-talk as efficient as possible,
right?
So that we don't have to wait forever for the AI to, finish thinking.
So how are they doing that?
Well, they're using things like parallel processing.
Parallel processing.
So that the AI can, like, think through multiple options at the same time.
Got it.
And they're also coming up with, like, optimized algorithms to speed up the whole deliberation process.
Okay, makes sense.
And it's not just about speed either.
Okay.
Researchers are also working on making self-talk more transparent.
Oh, that's interesting.
Yeah, so that we can, like, peek into the AI's thought process.
I see.
And understand how it arrived at its conclusions.
That's really important,
especially when AI is making decisions that affect our lives.
Absolutely. We need to be able to trust it.
Exactly. We need to understand why it's doing what it's doing.
For sure.
So to kind of wrap things up, what do you think are some of the big implications of self-talk in AI?
Oh, man. I think the possibilities are endless.
Right.
Like, imagine AI that can design new scientific experiments.
Ooh.
Or, like, come up with solutions to global problems.
That would be amazing.
Yeah. Or even write, like, incredible stories.
AI storytellers, that's a wild thought.
That's a whole new world. You know?
It really is. But with all this potential, I think it's important to be careful, yeah.
Of course.
As AI becomes more and more sophisticated, we need to make sure that it's
safe,
yeah, and beneficial.
For everyone.
And that it aligns with our values.
Right, like human values. You don't want it to go off the rails.
And the good news is that researchers are actively working on that.
They are?
Yeah, like incorporating ethical principles into AI design.
Oh, that's good to hear.
To make sure that it stays reliable and controllable.
That's reassuring.
It's a reminder that technology is a tool.
Yeah.
And we need to be the ones guiding its development.
Absolutely.
So that brings us to the end of our deep dive into inference and reasoning.
Wow. Time flies.
We started with the basics of logic.
Yeah.
And we ended up talking about AI that can, like...
talk to itself.
Think for itself.
Crazy.
It's been quite a journey. We hope you learned something new today.
Yeah, I know I did.
And that you're maybe even a little more aware of the incredible power of inference.
Yeah, absolutely.
Not just in, how you think, but also in the world of AI.
It's everywhere.
And it's only going to get more and more important as we move into the future.
It really is.
So thanks for joining us on this deep dive.
Yeah, thanks for listening.
Keep those inferences flowing.
Keep them coming.